Hello everyone, welcome back to my channel Archaeology. So today's topic is binomial theorem. Binomial theorem. So binomial theorem is a very important topic if you're talking about exams like JEE mains or olympiad exams or anything. So there are several questions that is totally based on binomial theorem. So what is binomial theorem and what kind of questions they ask in exams? Let's discuss. So first of all, binomial theorem definition. So what is definition? According to definition, whenever you have expressions like x plus a whole power n, where n is a positive integer. So whenever you have such type of expression, you can represent it like nc0 x power n a power 0 plus nc1 x power n minus 1 and a power 1 plus nc2 x power n minus 2 a power 2 plus up to last term will be ncn x power will be 0 because n minus n is 0 and a power will be n. So this is the expansion of x plus a whole power n. This is the normal definition of binomial expansions where n is, you can write it as where n is positive integer. And talking about nc, this is what this is, ncr, this is combination ncr, which can be expanded as n factorial divided by n minus r factorial into r factorial. So let's take an example how to represent ncr. And talking about factorial, do you know factorial? N factorial means what? N factorial means n into n minus 1 up to 2 and 1. So let's discuss what is n factorial and ncr. Example, suppose you have 4 factorial. So how to write 4 factorial? You can write 4 into 3 into 2 into 1. Okay, this is the factorial way. You can write any number like n, so you should write n into n minus 1 up to 1. And if I say what is 1 factorial, so obviously 1 factorial will be 1. And similarly 0 factorial, you should write 0, but 0 factorial is normally defined as 1. Okay, and talking about ncr, suppose you have 10c9. So 10c9 means you should write 10 factorial divided by 10 minus 9 factorial into 9 factorial. I am just applying the definition of ncr. So this will be equal to 10 factorial means you can write 10 into 9 and up to so on. So I am stopping at 9 only. So I am writing 10 into 9 factorial, as you can write 9 factorial as 9 into 8 into 7 into 6 up to so on. So you can stop at 9 factorial also. So 10 factorial will be 10 into 9 factorial, and this will be 10 minus 9 is 1 factorial, and this is 9 factorial. So as you can see, 9 factorial and 9 factorial cancelling, and 1 factorial means 1 only. So you eventually get the value will be 10 only. So 10c9 is 10 only. Similarly, you can write 10c8. So if I directly write, what will be the value of 10c8? This will be 10 factorial. 10 factorial, which is 10 into 9 into 8 factorial divided by difference. Difference is 10 minus 8 is 2 factorial into, and this r factorial, r is 8. So you should write 8 factorial. 8 factorial, like 8 factorial gone, and 2 factorial is 2 only. So you should write 10 into 9 divided by 2 into 1. So this is cancelling, you will have 5 only. So 9 into 5 is 45. So what is the value of 10C8? Value of 10C8 is 45. Similarly, you can write this combination type like NCR type in this expanded form. So binomial definition, you know, x plus a whole power n. You can elaborate like this. And now take some example. Suppose you have to write x plus 8 whole power 10. So you can write it as 10C0 x power 10 and 8 power, this is base value which is 0, plus 10C1 x power difference 10 minus 1 9, and second term is 8 power will be 1, plus up to so on, and last term will be 10C10 x power will be difference 10 minus 10 0, and second term 8 power will be 10. So this will be equal to 10C0. 10C0, you can, when you simplify this will be 1 only, and x power 10. X power 10 is there. X power 10 into 8 power 0 is 1 only, plus this will be 10 only, and this will be x power 9, and this is 8 plus dot 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 plus 10C10 is again 1 only, x power 0 means 1 only, and 8 power 10 means 8 power 10 only. So why I am writing 10C01? Because nC0, whatever is the value of n, this value is eventually 1 only. When you apply definition of NCR, you will get 1 only. And similarly NCN, NCN is again whatever is the value of n, you will get only 1. So with these two relations, what we trying to accomplish is your NCR is eventually equal to NC n minus R. You can put it, see here R value is 0 and n is any positive integer. So NCR NC0 will be NC n minus 0, which is NCN. You can apply it, or example for this you have example is like, you can write 10C7 is equals to 10C n minus R. R value is 7 and n value is 10. So this will be 10 minus 7, which is eventually equal to 10C3. So this property is very helpful. Whenever you need, you can apply it. So your 10C7 is eventually equal to 10C3. There are other properties also for NCR, like you can write NC R plus 1 divided by NC R is equals to, this is again another property, you can write it N minus R plus 1 divided by R. So this is another property. Let's see the verification for this. Verification. So NC R minus R plus 1, you can write it as n factorial divided by n minus R plus 1 will be n minus R minus 1 factorial and R plus 1 factorial, R plus 1 factorial. So I wrote this directly actually. So let's see whether it is true or not. We just verify this, and your NCR will be equal to n factorial divided by n minus R factorial into R factorial. Okay, so this implies NC R plus 1 divided by NC R will be equal to, just put the values, your n factorial will cancel out, okay, and this value will go upside and this value is downside. So you have n minus R factorial into R factorial divided by this value, denominator part. This is n minus r minus 1 factorial into r plus 1 factorial. Okay, so how to simplify further? So you can do one thing. The thing is, you can write it as n minus r. This is n minus r. Next term will be what? So you can write n minus r into n minus r plus 1, because we are subtracting bigger terms. So this is n minus r plus 1 factorial, r factorial as it is, divide by this value n minus r. You can write it as n minus of r plus 1 whole factorial into r plus 1. You can write it, and r plus 1 if you write in factors, so r plus 1 into r factorial. Now you can see this value and this value cancelling, this value and this value again cancelling. So what you are getting is, this is n minus r upon r plus 1. So with verification we can directly see this NCR plus 1 and NCR is equals to n minus r upon r plus 1. So whatever I wrote here is incorrect according to this verification. So this is equals to n minus r divided by r plus 1. Now talking about other formula. Okay, leave it. First of all, tell me what is the possible value of r if you have n. What you should write here, what is the value of r? R should be greater than equal to 0, correct? Because r value you can take 0, 1, 2, 3 up to so on. But what is the limitation for r? Limitation of r should be n na. This is less than equals to n. So whenever you have NCR, r should lie between this range. Okay. And one more formula, second formula is, if you have NCR and plus NCR minus 1, so this will be equal to n plus 1 CR. Okay, I can give you verification also, but this is formula, just you have to memorize this. Okay, because if you write expansion form of this and simplify, you will eventually get this one only. So this is another formula. And third formula is, and you can write n plus 1 C r plus 1 is equals to, you can take numerator and denominator part like this, n plus 1 and r plus 1 into this value. Which value? This value as NCR. Okay, let's go back to our definition of binomial theorem. What was the definition? X plus a whole power n is equals to NC0 x power n plus NC1 x power n minus 1 a power 1 plus dot 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 up to NCn x power 0 and a power n. This was the definition na? Okay. Now put a equals to 1. So this implies x plus 1 whole power n will be equal to NC0 x power n plus NC1 x power n minus 1 plus dot 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 up to last term NCn x power 0, because a value is 1 power anything is 1 only, so you can write in this way. Also you can write 1 plus x whole power n is equals to nc0. And now see, this x term is second one, not first one. So you should write nc0 plus nc1 x power 1 plus nc2 x power 2 plus dot dot dot, and last term ncn x power n. Also this ncr, okay, I am just talking about notation. So what are the notations? Your ncr is equivalent to cr, this is notation, and this is also equivalent to this bracket of nr. So these are three notations that you can use for ncr. So this term you can write 1 plus x whole power n is equals to this is c0 plus c1x plus c2x square plus dot dot dot, and last term cn x power n. Also this is not only this much, you can also write c0 is nothing but 1 plus c1, here power is n, so you should write n upon 1 factorial into x plus this is c2, so you should write n into n minus 1 divided by 2 factorial into x square. I am just putting the exact value of this, okay, plus dot dot dot, and last term is ncn and nc0 is same, I told you. So this will be 1 into x power n. With this you can verify so many formulas, like 1 plus x whole cube. So this is what? A cube plus b cube, na? A cube plus b cube plus 3 times of a square b plus 3 times of a into b square. Okay, so this was the formula na, in your previous classes this formula. So with binomial expansion you can verify this 1 plus x whole power n. Verification, verifying, or you can say anything. Verification 3 power 3 is equals to c0 plus c1x plus c2x square plus c3x cube. So you cannot go further because your r should be less than or equal to this power n. So this will be equal to 1 plus c1 means 3 upon 1 factorial, so only 3x plus c2 is 3 into 2 upon 2 factorial, so 3 into 2 upon 2 factorial into x square plus c3 is 1 again, x cube. So this is 1 plus, write this x cube, plus this is 3x plus this will be 2 and 2 cancel, 2 factorial is 2 only, and this is 3x square. So see, this value and this value is exactly same. So this is just a use case of binomial expansion, or you can say binomial theorem. So thing is a number of terms in a plus x whole power n. How many number of terms in this expansion? So you can see when you have power 3, so how many terms you have? 1, 2, 3, 4. Similarly, when you have power 2, you will have 3 terms. So in general, number of terms in a plus x whole power n is equals to n plus 1. One more terms. You can verify it by expansion. And second thing is, if you have x plus a whole power n and plus x minus a whole power n, so what will be the value of this? This will be exactly equal to, when you expand this is c naught x power n a power 0 plus c1 x power n minus 1 into a power 1 plus dot dot dot, and last term is cn x power 0 a power n, and plus sign is there, yeah, plus sign is there. Expansion of this will be same expansion, but this a value should be negative, so c naught x power n and minus a power 0 plus c1 x power n minus 1 into minus a power 1 plus dot dot dot, and last term we don't know value of n, either it is positive or negative, or you can directly write cn x power 0 and minus a power n. Okay, when you do mode simplification, this will be equal to c naught x power n plus c1 x power n minus 1 into a plus dot dot dot, and last term cn a power n. Okay, and plus c, this is minus a power 0, so this is only 1, so you should write c naught x power n and c minus 1 power 1 or minus a power 1, so minus term minus sign will come out, so you should write minus of c1 x power n minus 1 into a plus, because minus a, when minus a have power even, so minus sign will cancel out, and when minus a power have minus a has power odd, then minus sign will be there, it will show in this plus and minus case, or you can say minus sign will come out when you have odd power. So you should write this one will be c2 x power n minus 2 a power 2 minus dot dot dot, last term we don't know whether it is a minus or plus, so you should write plus of minus 1 power n cn a power n, a power n. So you can clearly see this 0 0 will add up, this 1 and 1 will cancel out, because positive sign and negative sign terms are same but with different sign, so this term will cancel. And similarly, in general, you can say even power terms of a will add up and odd power terms of a will cancel out, so you will get 2 times of c naught x power n plus c2 x power n minus 2 a power 2 plus c4 x power n minus 4 into a power 4 plus dot dot dot, last term we don't know whether last term is positive or negative, so leave it, means you can write like this only. So this is the expansion of x plus a power n plus x minus a whole power n. Similarly, when you do expansion of x plus a whole power n minus of x minus a whole power n, you will get 2 times of, this is sum of even terms, but when you do minus you will get sum of odd terms, so that is c1 x power n minus 1 a power 1 only plus c3 x power n minus 3 into a power 3 plus up to so on. So when you do sum, you will get 2 times of sum of even terms. When you do subtraction, you will get 2 times of sum of odd terms. These formulas are very helpful to solve some questions related to these formulas. Okay, now talking about number of terms. Number of terms in x plus a whole power n minus x minus a whole power n. So how many terms are there in this form. So if I directly say there will be, this all always depend on value of n. Okay, this always depend on value of n, whether n is even or whether n is odd. So there are two conditions. One is n is even, second is n is odd. So when n is even means, when n is even, so in this expansion there are n plus 1 terms, means odd terms. Okay, and in this expansion again n plus 1 terms, so odd terms minus odd terms. So when you subtract odd terms from odd terms, and you know that 50% of term will cancel out because of this negative sign. So you will have total terms like n plus 1 divided by 2. And when n is odd, so n plus 1 will be even. So you will get n by 2 plus 1 terms. So these are formulas. Verification is important, but we do not have that much time. You can expand this and expand this. This is in general form, and can be any number like 10, 11, something like that. So in general, whenever they ask number of terms in this expansion, you should write like this: n plus 1 by 2 and n by 2 plus 1. Okay, there is a little mistake. Mistake is when n is even, there will be n by 2 terms, and when n is odd, there will be n plus 1 by 2 terms. Okay, this was just a formula. Okay, and similarly, if I ask you number of terms in x plus a whole power n plus x minus a whole power n, so there is again two conditions: when n is odd and when n is even. So when n is odd, you will have same like n plus 1 divided by 2 terms, but when n is odd, n is even, then you will have n by 2 plus 1 terms. So this is something that you have to memorize, or you should have to expand this. Otherwise, okay, you have to memorize, or otherwise you have to expand this. Next thing is, whenever you have expansion like this, so there is a concept of general term. General, general term. So what is general term? Suppose this is the expansion. Okay, we know this is expansion. We can take any number like inside this. So if they ask in question like find the second term of this expansion, fourth term of this expansion, or any random term of this expansion, so how to find? There is a general formula for this. And general formula is like, if you directly need to find t r plus 1th term, t r plus 1 represent r plus 1th term in the expansion of this, what is x plus a whole power n. So for this there is a direct formula. Formula is tr plus 1 is equals to ncr, first term is x, so you should write x having power difference n minus r, and second term is a, so a having power r. So this is the general formula for finding any random term like r plus 1. R plus 1 can be 1, 2, 3, 4, 5, anything. Okay, so example, suppose you have x plus 9 whole power 11. Okay, and they are asking find ninth term of this. So how to find? So you have this expression x plus 9 whole power 11, and they are asking for ninth term of this expansion. So first thing is you can do expansion and then you find ninth term of this expression, or you can directly apply general formula. General formula here, r plus 1 is what? R plus 1 is 9. This implies r will be equal to 8. Okay, so ninth term according to this general formula will be equal to T9 equal NCR. N value is 11, so you should write 11 C R. R value is what? R value is 8. Okay, and first term is x only. X power difference is 11 minus 8 is 3, and second term is 9. Power will be R value. Okay, so this much only. This is very simple to find any random term. Okay, so this is ninth term, very simple now. So you can find any term, any of the term with this general formula. Whatever expansion or expression they are giving, you can directly find using this general formula. Similarly, we have some other types of questions, but first of all, after knowing this general term, we have concept of middle term. Middle term. So what is middle term? Suppose you have expression x plus a whole power n. Case 1. When n is even. So number of terms will be what? If n is even, number of term is n plus 1. So n plus 1 is what? If n is even, n plus 1 is odd. Then middle term is middle term formula will be t, because odd now, so you can directly write t n by 2 plus 1. This is your middle term. Let's understand with example. If you have x plus a whole power 5, so here n value is 5. Okay, we are taking even terms, so you should take 4 even. So n value is 4. This implies n plus 1 is equals to 5 odd. So middle term will be equal to t n by 2 plus 1, which is equals to t 4 by 2 plus 1, and this is eventually equal to t3. So your third term will be the middle one now. Or you can directly understand, if you have 1, 2, 3, 4, 5. You have 5 terms, so what is the middle one? These two separate, these two separate. Okay, this 3 is middle na, 3 is middle. So with this you can find middle term of x plus a whole power n. This is case 1. Similarly, you have case 2. Case 2 when n is odd. When n is odd, that means n plus 1 is even. So there will be 2 middle terms, because suppose you have 1, 2, 3, 4. So what are the middle terms? You cannot say 2 is middle term or 3 is middle term. So you have to assume 2 middle terms, this one and this one. So formula for this is middle term will be t n plus 1 divided by 2 and t n plus 3 divided by 2. This is the formula. So there will be 2 middle terms whenever n is odd, and there is only one middle term, that is Tn by 2 plus 1 when n is even. So this concept is also important, middle term concept. Okay, next expression, type 2. Type 2. Suppose you have an expression like a x power p plus b divided by x power q whole power n. This type expression. So how to find general term, or how to find any term, whatever they asking. So with this form, what is the general term? General term. General term will be equal to T r plus 1, which is equals to NCR. First term is a x power p whole power will be n minus r, and second term is b divided by x power q whole power r only. So when you do some simplification, this will be equal to NCR a power n minus r into x power np minus nr into b power r, and this is x power q, but this is in denominator. When you take this in numerator, this will be x power minus, power will be negative, so you should write minus q, and r is in multiplication, so this is minus qr. Okay, do some more simplification. This is ncr a power n minus r b power r and x, this base and this base same, so you should write x power np minus nr and minus qr. So eventually you can take n common, so you have np minus nr minus pr. Okay, what is happening here? np minus nr minus qr. So this is the general term. So for this type of expression, if I say find term containing x power s, x power s is random. So if I ask find a term containing x power s in this expression ax power p plus b upon x power q whole power n, so what you do? You know general term is this one, and you know you need term containing x power s, and you have in general term x power this much. So eventually what you have, s should be equal to this expression, that is np minus nr minus qr, correct? S should be equal to this much. That after that you can conclude that there is a term containing x power s. So with this relation you will get r value. After simplification you will get r value np minus s divided by p plus q. Okay. So what we concluded that whenever you have such type of expression and in question they are asking find a term containing x power s, so what you have to do, you should have to find r value with this relation, that is np minus s upon p plus q, and after finding r value you can find that term containing x power s, that is t r plus 1. Okay, so this is the concept behind finding any term containing x power s. Let's do one example so that it will be more clear. Okay, let's take an example. Suppose you have expression 3 x power 4 plus 2 divided by x power 3 whole power 11. Okay, and you need to find term containing x power we can say x power 7. So how to find a term containing x power 7 in this expression? Let's see the solution. Here, as you compare, if you compare with ax power p plus b upon x power q whole power n, you will get p value equal 4, q value equal 3 and n value equal 11, and we have to find x power 7, that means s value is 7. So applying formula was r equal np minus s divided by p plus q. So when you put values, you have 11 into p value is 4 minus s value is 7 divided by p plus q is again 7. Okay, so I made up this question. I have to change something so that you will get integer value of r. So right now what you are getting 44 minus 7 divided by 7. So 44 minus 7 is, you will not get integer value, so we have to change something, and what we can do, okay, 44 you can find x power 9, make it x power 9. Okay, I just made this question right now, so we have to make properly x power 9. So your s value is 9, so this will be 9. Okay, so 44 minus 9 divided by 7. So what you get, 44 minus 9 is 35 divided by 7, this is cancelling, you will get 5. So your r value is equals to 5. So term containing x power 9 will be equal to t r plus 1, means t6, which is equals to 11c5. First term is 3 x power 4 whole power will be difference, 11 minus 5 6, and second term is 2 by x cube, power will be 5. So your required term is t6, which is equals to 11c5, and 3 power will be 6, x power will be 4 into 6 24, 2 power 5, and x power 3 into 5, this is denominator, when you take in numerator, x power will be minus 15, and you will get t6 equal 11c5 3 power 6 into 2 power 5 into x power 24 minus 15 9. Okay, so you finally get this value. So we will do some more questions and other stuffs, but for this video up to this only is sufficient. So what we discuss what is expansion, binomial expansion, what is middle term, what is number of terms in a binomial expansion, and what is the difference of same type like x plus a, x minus a type. Okay, how to find general term, number of terms, and what is the definition of NCR, related some properties. Okay, up to this only, and rest we will do in another video. So thank you so much, thank you, bye bye.